Good afternoon, everybody, and welcome to this session as part of the ESN Marketplace event, which is our technology and innovation showcase. Many thanks for being here, for joining us for this session. My name is Ray Arrell. I'm Head of Technical Development at Regen, and it's great to be chairing this session, and I'm really looking forward to digging into some technology and technical detail for the next hour or so, or for the next hour exactly, in fact. So for those who don't know, the Electricity Storage Network, the ESN, we are the voice of the UK electricity storage sector, and as a membership organisation that is run by Regen. This afternoon's session is part of a wider event that we've been running yesterday, today and tomorrow, the Annual Marketplace event, and we want to many thanks to our sponsors, Road Knight Taylor, Fluence, Swan Barton, and Schneider Electric for supporting the event that we've been running. For everybody who's joined us either via Zoom or via Hoover, welcome. Many thanks for being here. Please do introduce yourselves in the chat and let everybody know who you are and where you're from for joining us for this session. So today, this session is around storage technology and an innovation and technology showcase that we'll be running. Next slide, please, Hannah. So the success of the storage sector is fundamentally underpinned by the capabilities of storage technology and it as a technology sector. As you can see here on the slide, we've got a significant amount of storage that has already been deployed, around 1 gigawatt of battery storage, as well as the pumped hydro we've already got in the system, the legacy installations. But we've also got just under 12 gigawatts in the pipeline, whether that's planning, scoping, and potentially going forward to awaiting construction. But in order for storage as a sector to fulfill and meet its potential, we need new technologies to come forward alongside the existing technologies that we're seeing in the pipeline, and we need the existing technologies to improve what they do and have new capabilities and services that they can provide to the system. Next slide, please, Hannah. So as a sector, storage has benefited from some policy and innovation support and funding support, some of which you can see on the screen here. In addition to that, it's also been referred to, and more support for the storage sector has been discussed in the government's 10-point plan. And it's also interesting to see the number of different storage technology patents that are being registered in the UK as time goes on, which you can see in the diagram on the right there. Next slide, please, Hannah. So with all that in mind, the ESN is really excited this year to be launching a new member working group around technology and innovation. We'll be launching that later this year, and we are hoping this new working group will interface with the existing working groups that we've got that you can see there, and it's also going to be exploring new storage technologies and enabling technologies and how they benefit the system. We're looking to highlight and remove technical barriers from storage projects from fulfilling their potential and accessing markets and benefiting the system, and also use it as a working group to engage in innovation programs, consultations, and fulfilling and furthering storage technologies that are burgeoning and starting to emerge. Next slide, please, Hannah. So on to today. Today, we are having a showcase of some alternative storage technologies. So we're going to have 3 storage technology innovators. We're going to do a 5-minute pitch explaining their technologies and what benefits their technology brings. And then we have a panel of experts who are going to be quizzing them around their technology and how their technology can benefit the system. So I'd like, first off, before we move on to our first innovator, I'd like our panelists to introduce themselves. So we've got Marika Schmidt, the Innovation Lead at Innovate UK, Anthony Price from Swan Barton, and we've also got Julia Grove from Downing. So I'd like to pass over to Marika first, please. Just to
Hello, my name is Marika. I work for Innovate UK in the Prospering from the Energy Revolution team, which is a 102.5 million program that we're running. And my remit is finance, investment and enterprise.
Thank you very much, Marika. Anthony.
So I'm Anthony Price. I'm from Swan Barton. It's a storage consultancy which I've been running for coming up for about 18 years now. I've been particularly interested in storage for about 30 years, which is quite a reasonable period of time, I think. And I've been looking at all technologies, and in particular the way that technologies fit in to the electricity power market, and we can deliver a better power system through the use of storage. Particularly interested in new technology, and I've been working with many storage manufacturers over the years, trying to help them find a way into the market and then help the market find a way to adapt to new technology. So I'm very pleased to be with you today. Thank you. Thanks
very much, Anthony. And also a super quick thing I want to mention and congratulate you on your OBE that you received, and also for all the work you did on founding the ESN and taking it forward to where it is today. Lastly, but not least, Julia. Oh, you're muted, Julia.
So well done, Anthony. What a star. So I'm Julia Groves. I'm a partner and head of ESG at a firm called Downing LLP. We have about 1.2 billion funds under management, done about $500 million in renewable energy. Much more focused to date, I would say, on energy generation. But we did an IPO before Christmas for the Downing Renewable Infrastructure Trust, and increasingly will, of course, need to be looking at storage. So that's my professional hat on. I'm also an angel investor. I was the first investor, for example, in Become Energy, which became Pivot Power, which is a battery solution. Am I allowed to say batteries on this, or am I immediately going to cut off? Anyway, so from an angel investor point of view and a professional one, I'm probably coming to this in terms of scale and can the numbers work.
Thank you very much. So I'm sure you agree, an excellent panel. Some people are likening this session to a battery storage or energy storage Dragon's Den. It's definitely not that. We don't have a pile of money that unfortunately we're going to give to anybody, and there are no winners, losers here. It's a showcase of some emerging technologies and a chance to find out more about them. So before I hand over to our first speaker, this session is going to be a 5-minute pitch and then 10 minutes of questions from the panel, and then we'll be rotating to the next speaker. So let's move on to our first one. I'd like to introduce Charlie Blair from Gravitricity, who's going to be our first speaker. Over to you, Charlie.
Super, thank you, Ray. Ray, can you just give a thumbs up if you can hear me? Super, thank you. And really good to be here, and great. Thank you for the ESN for inviting us, but for existing as well. You've done a great job, and the ESN is particularly good at supporting technology development as well as project development, which has always been a really important thing, and I think will carry on being an important thing in energy storage. So it's great that this particular session exists, that there is a world outside lithium batteries, and that there's a requirement for stuff outside lithium batteries. We are one of many technology companies doing other technology stuff. Companies called Gravitricity. I'm managing director. We're based up here in Edinburgh. You might have guessed from the name that we use gravity to store electricity. We are one of several, I would say, around the world, companies doing solid weight gravitational energy storage. So the physics is the same as pumped hydro, but rather than using fluids and water, we're using solid weights and important direct rotary drives. So that picture in front of you, the winches there are electrically driven. We charge the system by lifting a very heavy weight in an underground shaft. That takes electricity from the grid, obviously. The gravitational potential of that weight increases as it rises up from the bottom of the shaft. Then we can store the weight anywhere we like, a fully charged system or a partially charged system with no discharge at that point, and we can lower that weight back down again under control with the electric motors running as generators. So very simple technology in some senses, but it has some very particular advantages, and we think both commercially important and actually important for the wider global energy transition. Myself and my two co-founders have a background in clean energy transition and clean energy generation, it's so clear that we need energy storage and other flexibility solutions, as well as just generation technologies. So, sorry, if you could move on, Hannah, that'd be great. Here's a sort of big long slide of the unique selling points of Gravitricity. I'm not going to give you very long to have a look at it all. I will actually put it back on at the end if the panel want to be asking questions. But Hannah, if you could jump to the next one. This is a sort of simplified version of it. The technology responds fast. I said it's a direct rotary drive, it's winches, and there's a constant torque on the system, so we can respond in less than a second. That means we can access the highest value, the frequency response, enhanced frequency response type applications. It's extremely durable, 75,000 cycles until we replace the cables. The core of the system, though, will be lasting for hundreds of thousands of cycles. That's orders of magnitude longer than pretty much any chemical battery. And cost effective is the probably single most important one. If you can't be cost effective, it's not going to be worth doing. We've done a lot of work to validate our cost assumptions, and particularly our levelized cost of storage modeling. So if we have a reasonably long project life, and we think that looks like being 10 to 15 years, then our technology looks extremely competitive. So our technology is not about competing with lithium batteries in the short-term applications. It's about deployment in long life applications. And next slide, please, Hannah. And this is our market. As I said, it's not every single place where lithium batteries are deployed, but it is a very, very large market, 620 billion. We actually think there's a sort of bigger and more exciting market as well in storage deployed, built into electricity grids as an infrastructure asset. And Anthony, I'm interested in your views on that proposition. But for us in the short term, our beachhead market, if you like, is existing mine shafts. I said we drop very heavy weights and we raise very heavy weights in vertical underground shafts. If the shaft is already there, that clearly reduces the cost. And we are working on projects at the moment in Central Europe, Czech Republic and Poland, particularly where the coal mines are closing, but also South Africa, Chile, India and Australia. The long-term market, and this is one people sometimes find difficult to believe, but we actually think every time we look at this in more depth, it looks more and more commercially exciting and viable, is deploying shafts, new shafts, exactly where storage is required. And we would clearly only do this if there was a long-term requirement in a particular location. But actually the way the electricity system is emerging in Europe and North America with electric vehicles, for example, and particular locational strains on the grid, but also, and hence the picture of Africa, as electricity grids are expanding around the world, building storage into those grids enables less money to be spent on copper. And that storage needs to be long life. It needs to have a lifetime equivalent to other electricity system assets. So that's 25 to 50 years. Next slide, please, Hannah. So this is our team. We're based up here in Edinburgh. Myself, Peter and Martin are the three founders. If you know clean energy, you might have come across Peter and Martin before. Martin's chair of the REA. Peter has an OBE, I think, for services to marine energy. They were the founders of marine current turbines. And from a commercial point of view, interesting because they've sort of done it before in terms of developing a heavy energy technology, working with industrial partners and actually getting to an exit from an investment point of view as well. We're now a team of 10 full-time based here in Edinburgh. There's actually a couple of new engineers added to that team, mostly mechanical and electrical engineers, plus some business development and project development. Increasingly, we're becoming civil and mining geological engineering expertise as well. And very importantly, don't worry about the text in the bottom right, but we're working with industrial partners. We are not trying to reinvent the wheel, and we're not trying to actually become a fabricator ourselves. What we're doing is pulling together bits of industrial technology that already exist and doing the clever bits around configuring the systems and understanding how they interact and developing the control systems, which is a large part of our IP.
Just coming to the end of time there, Charlie. So if you could just make your final points, if that's all right.
Yep, sure. So we got 6 patents on that IP thing. Next slide, please, Hannah. This is the R&D plan. great news that we actually have pictures of actual things being built. That's a 250 kilowatt concept demonstrator at the bottom, being deployed here in Edinburgh over the next couple of months. Full-scale system deployment, hopefully by the end of 2023. And from then, commercial projects in mine shafts and new shaft projects. And final last slide, Hannah. And just to put this slide back up to sort of show that vision, it's not just about keeping the lights on in the rich countries of the world, it's also getting the lights on and keeping them on in the poorer countries. And we think that's an extremely big market. So we've had 2.5 million seed money in, plus some grant. We've got 6 patents. We are raising Series A later this year. So if there are investors in the room, please do get in touch, particularly interested. We are EIS, family offices, impact investors, and corporate venture capital companies. We're interested in speaking to those. So thanks very much, and looking forward to questions from, I think it's the panel, isn't it, rather than the audience.
Yes, indeed. Thanks very much, Charlie. Really cool. Interesting run through, and a genuine alternative technology in that sense. So yeah, I'd like to pass over to my panel. Let's start off with Marika.
Yeah, thank you, Charlie, for the presentation. Great to see a bit more detail. My question, I guess, is because obviously I've been a head of operations in the past, is around how you're going to get from the demonstrator stage to rollout. And I'll tell you why I'm asking this question. We at Innovate UK, we often, as you will know, because I think all sort of companies have had funding from us, we often work with companies like yours, and the question is always, how do you actually scale this? So that's, I guess, my first question in terms of operations. How do you think will that work, and what kind of barriers might you actually face but when you do that? So I'm quite interested in how you're going to get from this demonstrator project to scale.
Yeah, it's a very good question, and it's sort of fundamentally important. That's our sort of challenge over the next 2 or 3 years. We've now built this concept demonstrator, or effectively built it. We need to be raising money in order to fund those next 2 or 3 years. And then we need to be pulling together the special purpose vehicle to build that first project. And it is that first semi-commercial project that is the key and the important one here. Our business model has always been about recognizing that we're a small team here in Edinburgh. We can't be building a 10 million, 20 million euro project ourselves, or we could build it, but it makes more sense to work with partners to get to market quickly. And that's very much our plan. We're working with Houseman, which is a winch manufacturer based in the Netherlands, for the core heavy lift system and the design of that. And we'll work with partners on the EPC side and on the other electrical OEM components. So the idea is having those big players behind us enables us to provide the warranties and so on to give confidence to customers. We've actually got a lot of, certainly, particularly in that beachhead market I talked about, customers getting in touch with us. They have mine shafts. They want to do something useful with those mine shafts, but we have to give them confidence that we're serious and we can actually build projects and potentially take on liabilities. So the other thing to note is our business model is not about building projects. Our business model, Gravitricity, is about selling equipment, expertise, and O&M actually into project developers. And that's because if this technology works, it works everywhere in the world, and the markets all look so different. We don't want to be developing projects in Korea, in Japan, in India, in everywhere else. We need to be working with partners or customers who are developing those projects and buying equipment from us. But the core thing about getting to market quickly is this industrial consortium. It's working with players rather than reinventing the wheel. And that's a very interesting strategic challenge. And it's great that our chairman has done it before through MCT.
Great.
I should note before you go, Marika, thank you. We have received best part of 700 grand from Innovate UK, from the Systems Innovation funding. So it's great that Innovate UK is out there, and we do expect we hope to get some more innovation funding, whether it's from Innovate UK, possibly Europe, if projects there. That's another part of that funding question.
Okay, great.
Thanks very much, Marika. Julia.
Charlie, you said at the start that you had direct rotary drives, which was important. Can you elaborate on that a bit more?
Yeah, sorry, but it wasn't a very technical phrase necessarily, but it's really about the fact that rather than a pump, which is it's kind of using that sort of motion to move stuff, where a winch is just a cotton bobbin, and you're winding it up, and that winding motion is rotary. And in order to generate electricity or to use electricity to do motion, it's rotary motion, if you see what I mean. So that means we don't have losses. And one of the slides on the USP, the bits in the USP, was that we have better or just as good or better round trip efficiency than any other electricity storage technology. But it also means we can respond fast. We have that constant torque. And actually, because the weight is moving relatively slowly, we can get up to that speed accelerating under gravity really very quickly. So
that's one of the questions that's come through from Ian Tanner. So his question was, is the under 1 second response to full output, and would it meet DC requirements?
Yes, it's AC to AC is always our challenge on that. So yes, I think. I'm not the electrical engineer, so sorry if that's not clear on the DC requirement bit. And yeah, it's absolutely, it's actually, we hope, from full charge to full discharge.
Great.
So
and then my only last quick question was
twice as fast.
I was intrigued by the concept of, you've talked about where the shafts are already, but also the potential to put this exactly where it's needed. What does that do to the unit economics, though, if you've got to build a shaft? Shafts don't look cheap, Charlie.
Shafts aren't cheap. You're absolutely right. And the shaft sinking technologies that currently exist are very good. It can be done, but it's relatively expensive. I say relatively. It doesn't necessarily, for example, double the cost of the whole system. It's surprisingly cheap in some ways. Or you could say the winches are surprisingly expensive. But either way, there are reasonably significant costs to do with taking the existing mine shaft. So the extra costs are there, but they're not necessarily huge. And the economics of a sited solution are different. I should note that we're not going to sink mine shafts that are a kilometre deep. We would be sinking shafts that are shallower and probably wider. And it's an R&D program to work with the technology companies making shaft sinking machines. It's not really new technology that's needed, it's new techniques. We need to be able to reuse the machines, for example, and that can bring the cost down massively. So it's one of these things where there's no fundamental reason why it needs to be expensive, but it is. We need to get over that barrier, but that's the next step. We want to prove the mechanical electrical bit first in existing mine shafts. And we actually think there are thousands of them around the world that we can deploy.
Okay, thank you.
Cool.
Thanks, Charlie. Anthony, over to you for our last set of questions.
Anthony, you're on mute.
That was absolutely great. Fantastic, very interesting overview. And I think, from the start, mechanical systems always appeal because they seem to go on for a lot longer. So you've got some great advantages there. But I was surprised, perhaps that's too strong a word, but you were talking about replacement of the cables. And I think you gave an example of 750 cycles to replace the cables. I'm not sure if that figure is correct.
75,000.
Yeah, well, listen, Julia, 3 zeros are out, Anthony.
Okay, well, in which case I misread then. So that rather deflates my question on that. And then could you just talk to us about the O&M required to keep this thing operating safely?
Yeah, absolutely. It's a sort of fundamental assumption in our levelized cost of storage modeling that the O&M cost will be low. So we don't have any ongoing air conditioning costs. We don't have any operating costs as such. It's standard maintenance. Winches are extremely well understood. The bit that is much less well understood is shaft condition monitoring. So that becomes actually a large important part of our IP as we go forward. Cable monitoring is the other bit, but we are working quite closely with a cable manufacturing company, Bright & Beckart. We're also, it's a core part of what Houseman do. So there is an assumption in all of our modeling that O&M costs should be low based on some sensible engineering work. We'll be doing more work to get better detail on exactly how low those are going to be. But again, we come back to the industrial consortium. They would be providing the warranties and be providing the O&M capability to keep it low. But simplistically, a winch, mine hoists, if you like, they operate tens of times a day. And there's one actually here near us in Scotland at the Mining Museum that's been operating without any refurbishment ever since the 50s, I think, electrical mine hoist. they are extremely durable bits of kit. The cables themselves that's the bit that will need replacing, but 75,000 cycles, that's an order of magnitude bigger than the full lifetime of a lithium battery primarily. So it's really, it enables us to cycle many times. And from a commercial view, that's exciting because it either means you can get lots and lots of cycles in a short amount of time, or you can extend, you can extend for many years. But it also enables owners of assets to sweat that asset as much as they want without any worry about degradation.
So Charlie, that's a very appealing answer and gives me a great deal of confidence and enthusiasm, particularly the idea that you can then pass the warranty on to established players so that a purchaser doesn't have to take any risk in that. And if Ray, am I allowed one more question?
I'm afraid not, Anthony. I was going to say we are up. I'm going to play my my firm chair hand, I'm afraid. I want to say thanks very much to Charlie Ann for your great questions. Realise we're probably just scratching the surface of digging into this technology, and there are people itching, I'm sure, to ask Charlie some questions. But Charlie, I'm sure you'd be happy to dive in onto the chat and continue the conversation if anyone wants to ask them.
Absolutely.
About that. Many thanks for that. Great run through. So let's move on to our next speaker. So we're now going to, I would like to introduce Stephen Crocher from Reenergize to talk about his technology. Over to you, Stephen. And are we okay to switch the camera to Stephen's session?
I can't see Stephen.
Stephen, are you still with us?
Hi, yeah, I keep losing my connection actually at the moment, so I've dropped out 2 or 3 times while Charlie was speaking. So let's give it a go, and hopefully everyone can hear me.
Yes, we can. You're back with us at the minute. Yeah. Let's see how things go. Thanks very much, Stephen. Over to you. No, I think we might have lost you again there, Stephen.
Oh, can everyone hear me? I've just lost connection again.
No, we can hear you right now. Let's give it one more time, and then we might switch to Nick, and then maybe we can change the order up. See if you can sort some connection issues out. Are you with us at the minute? I don't think you are. Okay, Hannah, if it's all right, Nick, if you're also ready, apologies for bumping the order, but whilst hopefully Stephen comes.
I'm here at the minute, but I have very poor sound quality. I can't really hear anything except.
Oh yeah, I think yeah, we've got some issues there, Stephen. So what we'll do, I'd like to introduce in that case Nick Kitchen from Cumulus Energy Storage, and over to you, Nick. If you're able to step in and change the order a bit.
Thanks, Ray. Hannah, could you possibly put the slides up if that's possible? Hannah?
Oh, I've got the slides here if needs be.
Charlie's feeling really smug now because all of his tech work.
Some tech issues. Well, oh, there we are.
Okay, all right. So, so good afternoon, everybody. So my name is Nick Kitchen. I'm CEO of Cumulus Energy Storage. And essentially what we're doing is we're enabling more renewable electricity to get to where it needs to get to at the right time. We're using our own patent-granted rechargeable copper zinc chemistry and batteries to do this. Our patents cover approximately 2/3 of the world's total electricity generation, just to give you a feel for scale. Currently, we've raised 3 million in terms of equity finance, plus a further 1.5 million from the UK government for grants. And we're currently raising 5 million equity to facilitate us to have a pilot line and get to commercialization. So next slide, please, Anna. Thank you. So the problem is climate change, backed up with legislation, is driving the global electrification, which we've been talking about during the conference so far. So transport, heat, and of course, we're completely changing the way that we generate electricity. So a lot more decentralized renewable generation. And the difficulty that that then leads to is how do we balance the grid? And this is part of the issue that Cumulus is going to help to solve. Next slide, please, Anna. So just to give you a feel for some of the symptoms, so the wind constraint payments that were made to by National Grid in the 12 months for 2020, we got a snapshot of what the increased renewables, what the impact of that increased renewables has on the overall costs of the wind curtailment. And wind curtailment is just one of the balancing costs for National Grid. You can see that between 2019 and 2020, those costs nearly doubled, more than doubled, in fact. So total balancing costs for National Grid last year were basically just over 1.75 billion. So this is a significant cost that obviously the consumers need to bear at the end of the day. So next slide, please, Hannah. So climate change, as I've mentioned already, is driving the increased variable renewable electricity. So this is specifically solar plus onshore and offshore wind. You can see from the graph on the right-hand side where the total electricity generated last year was for various countries. And you can also see where they're planning to be between now and 2030. So every one of those pretty much is more than doubling where they are currently. So this is driving the market for energy storage, but not just short-term energy, short-duration energy storage, but much longer duration storage. And that's where the whole marketplace is going, which has been talked about again at the conference already. Next slide, please. So Cumulus is part of this solution. Obviously, we need demand-side response and energy storage, a whole range of energy storage that goes from seconds to seasons. Clearly, given that we're trying to resolve climate change, it makes sense to have an environmentally friendly solution, which is what we're delivering. And our rechargeable copper zinc energy storage essentially has a 4 to 6 hour charge time, 4 to 6 hour discharge time. We are able to also take part in the ancillary services market because our response time is measured in milliseconds, not longer the duration than that. But essentially it's a 4 to 6 hour duration, which is ideal for integrating wind, solar. We're using abundant metals, so copper, zinc, stainless steel, aluminium, available from everywhere in the world, no supply chain issues. Even our electrolyte is biodegradable. So, and the other beauty is that we're 99.5% recyclable. We have one wear component, it's the membrane. We can change that very easily through a maintenance program, but everything else can be reused. And it's, by the time we've done 3 changes of membrane, we're talking about a 30-year system. Thank you. Next slide, please. To give you a feel for what it looks like, 1 megawatt hour system fits into a 45 high cube container. Larger systems would be inside a building, and look similar to what you can see on the right-hand side. Next slide, please. So just to talk about the technology for a second, 7 cells on the left-hand side in series, same currents going through all the cells, exploded diagram of the right-hand cell in the middle, copper, zinc. So outside that we have 2 pressed metal pans. Those pressed metal pans clamp the membrane in the middle. Into the voids that we create as a consequence of that, we put our liquid electrolyte. So it's an aqueous battery, but it is not a flow battery. So that means the response time, as I said, is in milliseconds. A very simple system, and essentially what we're doing, we're just moving metal in and out of solution. Next slide, please. 2 key unique selling points. Firstly, it's safe and reliable. And the second point is its lowest projected levelized cost of storage. And if anybody's listening from the automotive industry, we're really keen to be able to utilize our assembly process, our assembly plants, to be able to re-employ some people from the automotive industry into the energy storage assembly plants that we want to set up. So there are lots and lots of similarities between our assembly process and that for the automotive industry. Next slide, please. Applications, numerous. I'm looking here at 4 to 6 hour applications. It runs from integrating the renewables, whether that's solar PV, onshore, offshore wind, into the transmission distribution network, onto data centers, that site energy management. That's a massive market that's coming good right now. Diesel engine genset replacement all over the world, but particularly mining. And then, of course, from a demand point of view, the electricity intensive industries is another big opportunity for us. Next slide, please. Competitive landscape, we're at the top right hand side of this, low cost and also environmentally friendly, just to give you a feel for where we perceive other players in the field lie. Next slide, please. So project pipeline, we've got a number of universities in the UK and elsewhere around the world that are interested in putting our systems in at relatively small scale, but we've done 2 feasibility studies, one in Ireland for what could be up to 100 megawatt, 400 megawatt hour system in 3 phases. And then the second one is another project in the southeast of England, which would, if it was to go ahead, would be for co-locating with a 30 megawatt biomass plant. Next project. Next slide, please. Management team, very experienced, 2 MBAs from London Business School. Mike's got a master's level degree in battery engineering. Mike's name is on the patent. Lots and lots to say about the management team, but I won't go through them in detail now. Next slide, please. Just to give you a really basic feel for financial roadmap, you can see on the top line, hopefully some feel for scale that we're talking about. And then further down that table, you can see the number of megawatt hours per year and the number of people. Final slide, please, I think.
I was going to say final points, please, Nick.
Yeah,
right.
sure. So the investment opportunity is 5 million equity we're looking for now. 4 things: completing the engineering product development, building the team, establishing a pilot line production, and then using that to produce containerized systems to go into the field so people can see it performing. Next slide and final slide. So essentially, this is about enabling more renewable electricity. It's a very cost-effective, environmentally friendly solution, and this is what's going to help drive some of our customers to empower the low-cost, low-carbon economy. Thanks so much indeed.
Great stuff. Thanks very much, Nick. An impressive and interesting alternative battery technology. Let's go to Anthony first this time. Anthony, what would you like to ask Nick?
Right, great. And I remember to unmute my microphone. Nick, very interesting, very good concept of a battery. Seems to fit. It's a bit of a long duration battery, which is always a bit of a challenge in the world where highest remuneration seems to come for short-term batteries. But could I just ask you to explain a little bit about your process for manufacturing these batteries? Are you going to build a factory? How long is it going to take you to build a factory? Do you need specialist skills to build it? Where do you get it from? You know, we've heard about the length of time taken to throw up gigafactories for building lithium cells. What's the complication? What's the difficulty for you to build a factory to make your cells?
Okay, so compared to lithium, firstly, our capex cost for if you like a gigafactory or a large scale production facility would be about 10% of that required for lithium. Right. It really is very, very simple. So an industrial building, as long as it's got an epoxy floor in it, is what we need. We don't need to go through all the positive pressure and everything else that's required for lithium. We have a 6-step plan. I won't run through all the 6-step plan right now, but that's available for anybody that's interested to look at more detail. That covers an 18-month program. It's 12 months from investment to get through to initial commercial sales. And we have two stages in that really. Firstly, we need to finish off the product development bit, a lot of which we can do in parallel with the design work for the production. The actual production process itself is very simple. We have an electroforming process where we put the copper and the zinc on the inside of the metal pans, and then most of the rest of it is an assembly process. When we get through from that pilot line to full production, if you imagine then an automotive plant with robotics and automatic guided vehicles producing something like 500 megawatt hours to a gigawatt hour per year, that's the kind of process and production volume that we're thinking about for a larger scale production. And then the vision is to be able to replicate that in various parts of the world so that we work with JV partners, where those JV partners are able to, through their local knowledge and their balance sheets, able to put those plants in place and then follow up with that with the sales and marketing activities for those specific continents. So this is a continental level JV partnership using a licensing arrangement with those JVs, so they can utilize our IP, but they then power that. So Cumulus Energy Storage Limited can be a relatively small company, but Cumulus Energy Storage as a group can be absolutely massive.
Thank you. Am I allowed one more, Ray?
I think we'll keep keep going for now, Anthony, but we might be able to come back to you in a minute.
Thank you.
Thanks very much. Let's move on to Marika.
Yeah, obviously we're seeing quite a shift in terms of net zero technologies at the moment. Systems are changing, just to describe this a little bit. So the question that I have is around the biggest barriers that you face at the moment. What's your biggest challenge really in terms of implementing this at scale?
Well, that's a very easy question for me to answer because it's called cash.
Okay.
So once the equity finance is raised, we then have the ability to then set up production, to then have a product that people can come and see at containerized scale. That then means we then attract interest from all over the place. But the trick, and the difficulty, if you like, in terms of challenges, is getting that equity finance in place to then be able to make the product. I've had I'll be honest with you, I've had numerous conversations with various investors about, we are very, very interested in putting money into you in the B round, by which time obviously you'll have a product, but we need the money to make the product so you can have a B round. That's the conversation we've been having for quite some time. That's the issue. It's not just Cumulus, it's anybody that's in the energy, in the capital intensive part of the marketplace. But that's the biggest barrier we've got at the moment. Having said all that, because of what's going on with COVID, because that's opened people's eyes with regard to the impact of increased renewables in the electricity mix, because of that and climate change generally, we are getting people from various parts of the world coming to us at the moment, strategic corporates, ultra high net worth individuals, specifically focused on our longer duration storage, because they all know that it's going to move from the ancillary services, 1-2 hours duration as the optimum. It's going to move to much more the merchant markets, the arbitrage opportunities, the integration of offshore wind, onshore wind, etc. And that is a 4 to 6 hour duration requirement. So the marketplace is moving. California is already there. So that's what people are looking for. So we're in the right space in between, if you like, the flow batteries and the lithium. So this will. So
leaving finance and investment a little bit aside, I totally appreciate that's usually the biggest barrier. But let's think a little bit ahead as well. Can you foresee any regulatory barriers that you might face, particularly in the UK?
Regulatory barriers. So I think one of the things that's been good from the conference that's been going for the last day and a half is that there is tangible demonstration that the energy storage market is changing.
Mm-hmm.
There are a lot more revenue streams available now than there were, say, 12 months ago. From a regulatory perspective, there are lots of changes taking place that are helping to drive. There's a way to go, to be fair, but a lot of things that are changing to help drive that right now. So it's positive.
That's really great to hear, because we don't always make this experience with our projects, and we often have battery storage involved, as you will know. So thank you for that. Yeah. Sorry, Julia.
It's coming good. It's coming good.
Julia, I do think we've got time for a question, if you do have one.
Yes, no, I'm just saying, don't interrupt Marika when they're talking about the last slide, Nick, I looked at very quickly. It looked like you were growing in lumps of about 5 million. Is 5 million something like the cost per installation, or have I misunderstood that?
No, if you take a sort of 250 kilowatt, 1 megawatt hour container, then that would be circa £300,000 per container, or £300 per kilowatt hour. But when we start to get at scale, then we're talking more like £150 per kilowatt hour.
Right.
That's not just for cell level or pack level. That's actually a complete AC system level.
Okay,
because really that's a low cost system.
That's a really interesting number for investors to have a look at.
It really is. And the thing that drives that is the fact that we've got really low cost materials. And that fundamentally is the bit that means we can drive down to this to be the lowest cost, or one of the lowest cost providers in the marketplace.
Perfect. And I mean,
copper and zinc are inherently low cost materials.
Yeah, the 5 million ticket is tricky at the stage that you are at. I would definitely encourage you to look at co-investment, because, you know, VCs inherently feel much more comfortable if somebody else is going in at the same time from that point of view.
Sure.
But
And we're very, very happy to do that.
Is there any value you see you could get from your next funder beyond the money? So any other problem that you would like them to help you solve?
Well, one of the strategic corporates we're currently talking to is $1 billion turnover business. They own about 100 companies, and their geographic span is global. So they can help us establish supply chains. They can help us establish JVs. They can help us from an engineering point of view. The list is a long one.
Yeah, sounds
so
logical.
that's just one of them.
Okay,
yeah.
Thanks, Nick.
Okay.
Thank you very much, Nick. I think, unfortunately, Stephen is still having some connectivity issues. So Hannah, I know, is going to try and help you out, Stephen. I think what we'll do at this point is, if we could actually bring all the panelists and Charlie and Nick back in together, I think we'll sort of revert for the sort of last 10-15 minutes to a bit of a discussion. And I'd like to actually ask a question myself, possibly a bit more of an ESN focused question, this one, selfishly, but with the aim for us to launch a new working group around technology and innovation. What would be your key ask of us as a working group trying to help alternative technologies come to the fore, move from R&D to commercialization? What would be your key ask for you representing alternative technologies for us to look to do? Maybe come to you, Charlie, first.
Yeah, sure. It's something I've pushed for quite a lot in the various groups, sort of representing different bits of the energy storage world. Primarily, it's about articulating the fact that lithium batteries don't do it all, really, and that however you look at the world, either the lithium's running out, or they don't last long enough, or they're explosive, or my one is that lithium's great, it should be in electric vehicles, and we should be using other technologies for grid connected stuff. It's articulating that fact that storage isn't done and dusted just because we've got gigafactories of lithium. We need other stuff. So, and that's sort of wide and general. Within that, in a bit more detail, there's the sort of policy arguments in there as well, and making the arguments to Marika and UK government, again, that it's not all about lithium, that it's frustrating for us that the Faraday Challenge is a kind of, it's looking at electric vehicles. That innovation was done 10, 15 years ago in Japan. I hate to say it, but it feels slightly like a shutting a door after the horse has bolted type thing. We need to be having a vision of the future, including other technologies out there. And for us, our focus, yes, we've got lots of mine shafts in the UK, but our focus is very much not on the UK. So it would be really nice to see all of the argument, the sort of support for clean tech not being tied directly to what we can do in the UK, but what we can do globally, because it really is the global impact that's going to make the difference for the polar bears. And it's also the global impact that's going to make the difference for the UK taxpayer and for UK jobs and everything. So I find it frustrating sometimes. So from a lobbying point of view, those are the sorts of things, Ray. But actually getting us together, I know Nick from ESN groups, I know Anthony from ESN groups, it's useful knowing human beings. So a lot of it is actually just having the gatherings. And a little plea, I would say, please don't always have them in London.
Okay, no,
have some elsewhere. But
Ray, I think what was interesting about Nick's stat, the one that really stick with me, is about the predicted growth, particularly if hopefully massive penetration of large scale wind, and how that grid payment is going to multiply, which just seems outrageous, doesn't it? From that point of view, the answer is obviously we're going to need all we can bloody get, isn't it, across all these technologies, and maybe finally sort of work out horses for courses from that point of view.
I think that's right. And sorry to butt in, but a thing that a group like the ESN can do really well on that is not just sort of articulating it, but actually doing some analysis. And sort of Bloomberg say you got these numbers, and the numbers go up each year, and they only really look at lithium. If James is here, he knows I have some discussions about that with him. but potentially as a group, paying for expert analysis that sort of tries to break down and tries to look 10, 15 years ahead, not at what we need next year. Because as Anthony and Nick have said, it's changing every month, not alone every year. And actually we are trying to develop technologies that are really going to make the difference in the 30s. So some form of sort of arguments about that. And again, I would say a global outlook, not necessarily just a UK outlook for that bit.
Appreciate that. Okay, thanks. My team in the background, Hannah and co, are furiously working to hopefully get Stephen to be back online. So we are, Stephen, if you're there with us, apologies for all the issues you've been having. But if we can revert back and hand over to you, hopefully this time your internet connection will be all good, and we can divert back to the format of the session. So over to you, Stephen from Reenergize. Many thanks.
No, thanks very much. And yes, always. Yeah, when you have technical problems, always a challenge. So I'll have to go quite quickly. I think this whole session finishes in about 10 minutes, so I'll have to go quite quickly to have time for questions. I would like to say, though, that for us, this is a little bit of a dragon's den because we launched on...
Oh, no.
I think everyone will be with me when I say no. So close.
So we're going to overfund a bit and keep going for hopefully a few more days. But I'll talk about Reenergize. So Reenergize, my name's Stephen Crocher, and Reenergize, we're developing a solution called high density hydro. Next slide, please. The world systems need to rapidly decarbonize to avoid damaging climate change. Next slide. And we know that the solution is renewable energy, but renewable energy gives us intermittent generation. Supply and demand don't match each other. Next slide. And our solution is very like conventional pumped hydro, which is about pumping up huge volumes of water up mountains when energy costs are low and releasing it and regenerating electricity through a turbine. Today, pumped hydro provides 96% of all the world's energy storage. It's not a battery solution, it's not anything else, it's pumped hydro. High density hydro is just like conventional pumped hydro, but rather than using mountains, we're using small hills. Next slide. When we think of pumped hydro projects, we think of installations like this. Next slide. Or like this, massive projects in mountainous locations needing huge vertical drops. Next slide. However, high density hydro can install projects on small hills that are found nearly everywhere. Next slide. Our team is highly experienced. Myself, Graham Cook, our CFO, and engineering is led by Tamas and Richard. And then supporting the team, we have a number of advisors and employees. Next slide, please. The market is huge. Other people have touched on this. £620 billion according to according to Bloomberg, and Aurora say that the UK needs 14 gigawatts of energy storage and flexibility by 2030. Next slide, please. We've done our own GIS mapping of the UK, and we can identify 9,500 sites across the UK, 80,000 in Europe, and 160,000 in Africa. So there is no shortage of sites, and only 300 sites could provide half of the UK's 2030 needs, according to Aurora. So what is our underlying magic? What is our solution? So we've developed a new proprietary high density fluid that we called R19. It has 2.5 times water. It's environmentally benign, low viscosity, low abrasion, non-reactive and non-corrosive. It provides 2.5 times more energy, and it can be installed on hills 2.5 times lower. And because of the density, it means construction can also be 2.5 times smaller, which presents huge cost savings compared to traditional pumped hydro, meaning it's faster and cheaper to build. Next slide, please. So in terms of the overall system setup, we're very much like a water system. However, rather than installing on mountains, we're installed on small hills in a buried closed loop system. Next slide, please. So we have 6 core subsystems, and where new IP is being developed across all 6 subsystems, and we've identified around 30 opportunities for IP across patents, licensing, design and copyrights, know-how and trade secrets. And this creates a robust IP moat for the business moving forward. We also have lots of opportunity for system commoditization, further driving down costs. We have a simple business model. We're an IP and knowledge licensor to energy infrastructure developers. And we believe that a project can deliver Reenergize with 2% of any project's capital costs and 4% of ongoing project revenues. Next slide, please. This is an example of the customers that we're currently engaged with. Next slide, please. Our competition, lithium-ion batteries, but we have no parasitic cooling loads, no degradation in performance, and few end-of-life liabilities, and we last longer. Also gas peaking plant, but we're a zero carbon solution for flexibility. And we can also provide real inertia. Next slide. We obviously compete with traditional pumped hydro, but that takes decades to construct. There's a shortage of sites, there's problems with water abstraction and environmental and social issues around flooding values. And with diesel generation, which is just dirty and polluting. Next slide, please. So, here's an example of using the Lazard methodology of how Reenergize competes on a levelized cost of storage with other energy storage solutions. Next slide. And a different methodology, one done by Jacobs at the end of last year, which compares long life energy storage technologies. And what's particular of note, that traditional pumped hydro is the lowest levelized cost of storage, and that lithium-ion batteries provide good solutions up to about 2 hours, but as the longer duration, they become phenomenally expensive. Next slide. And they're where we expect Reenergize to be, at the bottom of all of these different types of technology with the right sites. Next slide. And then in terms of what we can provide to the grid, we can provide the whole range of grid services. Some of these require different setups depending what a customer would typically want. Thanks very much. Next slide.
Final points, if that's all right, Stephen.
Yeah, I'm going to stop there. I'm not able to start my video because the host has stopped it.
Ah, okay.
There we go.
I think if it's okay, we'll move on to our panel. I think we may have some issues with that, I'm being told. But I'll tell you what, let's move straight to some questions. So let's start with Julia this time.
Rapid fire questions. So I love the idea of making a mountain out of a molehill, Stephen. That works particularly well. I think what he meant to say at the start is that they're in the middle of a pitch on Crowdcube, because clearly he's emailed me about that several times already. Thank you, Stephen, for letting me know that you're live and fundraising today. So if you can hear me, Stephen, I think the biggest question is, again, the single biggest challenge you need to overcome to make this a real success?
The biggest challenge is really about proof of concept. We just have to build a scale demonstration system to prove that really that we can operate a system over the long term. And when we ask potential customers what they mean by proof of operational capability, they're really talking about 2 winter seasons. So this is 15 to 18 months of continual operations in a demonstration test rig. And so our plan is to build that over the next 15 months or so, to build that operational test rig and then start doing the testing. And our customers recognize that our supply chain completely exists, that all of the manufacturers to provide the type of equipment that we need already exist out there. They're well capitalized, they understand how to build turbo machinery. There are suppliers of pipes and valves and things like that, which we can just tap into. Now, one of the things, introducing a high density fluid changes even though the overall architecture of all these system components is the same, the devil's in the detail. By introducing a high density fluid, the detail changes. So the pressure, even though volumetrically it's 2.5 times smaller, the pressures remain the same. Seal arrangements need to be different. Hydrofoil, the hydrofoil design is all different, which is, even though we're building on a century of knowledge, we're actually creating new IP, which is, and the people able to provide those parts are for our system. So we think from scale demonstration to commercial adoption should be incredibly short, because the component manufacturers are out there and able to warrant the equipment that we require for projects.
Okay. Thank you.
Thank you very much. Anthony.
Hi, Stephen. That was great. In terms of trying to ask you questions about the technology, there wasn't much that sort of came out from your presentation which I could hook into, but clearly the R19 is crucial to this whole argument. You said that it's environmentally benign, low viscosity, low abrasion. So a couple of questions on this. What does the Environment Agency think about this? And then also, could you just expand a little bit more on the nature of using pumps and turbines and other established mechanical machinery with this new working fluid, please? So it's, what does the Environment Agency think?
Yes, so we've had some very, yes, so we've had some very early discussions with agencies about how we'd go about certifying the fluid. So we're pretty confident that we will get to the point where certification of the fluid is relatively straightforward. We worked with in the early days with the Camborne School. They have a good understanding we're proposing to use and some of the underlying chemistry of it. And actually, so the fluid is a suspended solid in water, so it's a fine milled suspended solid, and actually the underlying mineral is also used in oral medical applications. So it is, you know, truly benign in terms of its use. What was the second part of your question? It was, oh, the impact on the machinery. So the overall architecture of the machinery is the same. Impact is quite significant. In reality, everything changes. So you couldn't effectively use a turbine that has been designed for water and expect it to work well with a higher density fluid. It would be off its design point. It would probably break very quickly. So even though the overall look of it looks almost identical to the untrained eye, the actual detail of the shapes of the impellers or the runners, or how the seals are arranged, or the casing thickness, the shape of the volute tubes, etc. And generating IP for the particular application of the high density within this type of machinery.
Thank you very much, Stephen and Anthony. Marika, over to you for our final question, unfortunately, of the session.
Yeah, yeah, my question is, I guess, around sites. So you said that you are planning to work with a number of partners, and I'm sorry, I can't remember any names, but I saw some water companies on there. And obviously, in your presentation, you also mentioned, of course, that this will be focused on smaller sites. Hills is what I remember from your presentation. So I'm just wondering about how that's going to work in sort of practical terms, because it's physical infrastructure. It's quite big, okay, in terms of also, you know, how will this work with local communities? How can you convince people to go for this technology, okay? And how are you going to work with partners on this? You know, how are you going to find all of these sites? I think is my question, and how many do you actually need to scale this as well? Have you thought about this? That's my question.
Yeah, so our systems are compared to pumped hydro, they're relatively small, but compared to the systems are, compared to something like pumped hydro, are relatively small, but in terms of infrastructure assets, they're still of medium size. So we're talking about systems of 10 to 50 megawatts in scale and 2 to 8 hours of storage. So they're reasonably meaningful in terms of the power and energy that they're able to deliver to a system. So they're well matched for co-location with reasonably large wind farms or solar assets. In terms of what it takes to physically build a site like this, we've probably all passed small water treatment works on the edge of towns where you have these concrete cylinders in the ground, which is part of the water processing work. So those tanks are typically 30 to 40 meters in diameter. And for us, a typical system is of a comparable scale, that you'd have 2 to 8 of those storage tanks containing the fluid, which they'd be roofed and landscaped, but so they wouldn't be visible. Certainly in the UK and other markets, they might be visible. But in terms of sort of infrastructure construction, they're relatively small projects, and the scale of projects that for a small one could be built in 9 months and a larger one is probably 15 months of construction time. So it's in the same sort of time scale of construction as battery projects or gas peaking park projects, which are probably a little bit quicker, but in the scale of delivery and construction delivery, they're in the same sort of order of magnitude. And the consenting time is probably the bigger issue for all of it.
That's what I was just about to ask, because actually with it doesn't really apply with smaller battery storage projects, the planning permission that you need and the whole process that you need to go through. So what are your thoughts on that? Because from what I understand, you're building, this is new sites. This isn't anything that you know is already there. So I'm just wondering about that.
Yeah, and I think the very first site that there'll be lots of questions. I mean, I think we have some advantages that because we can landscape projects, that actually once they're built, they become almost invisible. But I do think the very first projects are likely to be in disused quarries or sites where there's been a certain amount of man-made.
Oh, it's so frustrating. Oh, it's so frustrating.
Can you hear me okay?
Yeah.
Yeah, you're okay. Yeah.
So I think the first projects will probably be hidden from view, which probably suits us quite well, because we can put them on the surface in places like quarry, prove the concept, and then move forward onto more detailed customer engagement. And I think that's primarily what our early customers are also looking at, is where sites are co-located with other assets which are being built, either co-located with wind or solar projects, which looks likely to be our first sort of proper feasibility studies during this year. And then also grid connected assets on the same radial feeders as particularly wind assets in Scotland seem to be where customers are saying they'd like to install our systems first.
Okay.
Okay. Well, I've got to unfortunately draw this one to a close. But I think everybody here, I mean, with an electrical engineering background, I think I probably could carry on exploring all the technologies that we've been talking about today for another hour or so. So it just leaves me to say apologies that we've run over a bit and for the technical issues, but many thanks to everybody of the speakers and for the panelists and for everyone diving in on the chat and getting involved in the conversation today. If anyone is interested in finding out more about the ESN membership, part of that working group that I talked about at the start, please do get in touch. And obviously we've got networking sessions coming up. If you want to quiz Nick, Charlie and Stephen some more about their technologies, there will be other opportunities, I hope, in some of the networking sessions. But I'll probably leave it there. So many thanks to everybody involved. And our last session of the day will be at 4 p.m. And I wish you all a good afternoon and many thanks for being involved. All the best. Bye.